Welcome to this onboarding video from the Causal Inference in Public Health Research Lab. In this video, I will provide an introduction to traditional mediation analysis. The outline of this video is as follows. We'll start by laying out the basic principles of mediation analysis. Then we'll briefly go over mediation effects. In other words, what are the effects that we're interested in estimating when we do a mediation analysis? Then I will provide an introduction to traditional mediation analysis, and I will end this presentation with some take-home messages. Let's start with the basic principles. Often in epidemiology, we're interested in estimating the effect of an exposure on an outcome. For example, we might be interested in estimating the effect of sedentary behavior on blood pressure. In other words, we might be asking the question, do people who show more sedentary behavior have higher levels of blood pressure compared to people who do not show sedentary behavior? However, what often remains unknown in epidemiologic studies is how an exposure affects an outcome. This is where a mediator comes in. A mediator is a variable that is affected by the exposure and in turn affects the outcome. Therefore, a mediator is on the causal pathway from the exposure to the outcome and explains how an exposure transmits its effect on the outcome. In our example of sedentary behavior and blood pressure, BMI might be a potential mediator. The hypothesis here might be that people who show high levels of sedentary behavior on average might have a higher BMI, and that a higher BMI might translate into a higher blood pressure. So sedentary behavior in this case is hypothesized to affect BMI, and BMI in turn is hypothesized to affect blood pressure. Therefore, BMI is on that causal pathway between sedentary behavior and blood pressure, and explains how sedentary behavior transmits its effect on blood pressure. When building a mediation hypothesis, it's important to ask yourself two questions. The first question is, does a change in the exposure cause a change in the mediator? So in other words, if we were able to intervene on the exposure and we can change that exposure level, is it reasonable to assume that the mediator will change as a result of that? Then the second question is, does a change in the mediator cause a change in the outcome? Again, here we want to ask ourselves, if we were able to conceive of an intervention that could target the mediator, would that then result in a change in the outcome? In practice, we use subject matter knowledge to build these mediation hypotheses. For example, we might build these hypotheses based on information from previous studies or based on theories such as the health behavior theory. This is another example of a mediation hypothesis. In this example, childhood adversity is the exposure and quality of life is the outcome. Depressive symptoms is hypothesized as a mediator of the effect of childhood adversity on quality of life. The hypothesis here is that individuals who experience childhood adversity might on average have a higher level of depressive symptoms, and that a higher level of depressive symptoms on average decreases quality of life. So in other words, it's hypothesized here that childhood adversity affects quality of life through affecting depressive symptoms. This is another example of a mediation hypothesis. In this example, socioeconomic status is the exposure, cancer screening is the outcome, and health literacy is the mediator. The hypothesis here is that people with a higher socioeconomic status on average might have a higher health literacy, and individuals with a higher health literacy might be more likely to attend cancer screening. So in this case, socioeconomic status might transmit its effect on cancer screening through health literacy. This is another example of a mediation hypothesis. In this example, stress is hypothesized to be the exposure, and chronic obstructive pulmonary disorder, COPD, is the outcome. Smoking is here hypothesized as a mediator, such that individuals who experience a lot of stress might be more likely to smoke cigarettes. And individuals who smoke cigarettes in turn are more likely to develop COPD. So in other words, here we hypothesize that stress has an effect on COPD through its effect on smoking. This is the final example on a mediation hypothesis that I want to share with you guys. So here we have an intervention that is hypothesized to decrease BMI. And maybe the goal of this intervention is to get people to be more physically active. So physical activity here is hypothesized to be the mediator. So the idea here is that if the intervention can indeed increase physical activity levels in individuals, then this might translate into a lower BMI. You might have heard of third variables before, and mediators are actually a type of third variable as well. Two other types of third variables are confounders and colliders. Something that's important to know about all of these third variables is that they are statistically speaking exactly the same. All these three variables have an association with the exposure, and all of these three variables have an association with the outcome. Therefore, there are not any statistical methods that we can use to distinguish between a mediator, a confounder, and a collider. And this is also the reason why it's so important to build your mediation hypotheses using subject matter knowledge, because only subject matter knowledge can be used to distinguish between mediators, confounders, and colliders. So just to reiterate, a mediator is influenced by the exposure and it influences the outcome. And therefore, a mediator is on the causal pathway from the exposure to the outcome. Now let's contrast the mediator with a confounder. A confounder influences the exposure. It also influences the outcome. And because it influences both the exposure and the outcome, it is not on the causal pathway from the exposure to the outcome. So if we compare that with a mediator, we see that the mediator is influenced by the exposure, whereas a confounder influences the exposure. So that is the key difference between a mediator and a confounder. Now, if we go back to our earlier example with sedentary behavior and blood pressure, then age could be an example of a confounder. So people who are older might show more sedentary behavior, so age might affect sedentary behavior. And people who are older might on average also have higher blood pressure, so age also affects blood pressure. It's in particular important to note the green arrow here. The green arrow here points from age or confounder to sedentary behavior or exposure. And this is on purpose to denote that age affects sedentary behavior. This is also different from a mediator, because if we had a mediator in our figure, then the arrow would have been pointing from sedentary behavior to the mediator. Let's now also contrast the mediator with a collider. A collider is a variable that is influenced by the exposure. It is also influenced by the outcome, and therefore it's not on a causal pathway from the exposure to the outcome. And it's important to pay attention to that second point, because that's the difference from a mediator. So a mediator influences the outcome, and that's why it's on that causal pathway from the exposure to the outcome. But a collider is influenced by the outcome, and that makes that a collider is not on the causal pathway from the exposure to the outcome. Now let's go back to the example of sedentary behavior and blood pressure. Cardiovascular disease might be a collider of the effect of sedentary behavior on blood pressure. The hypothesis here might be that people who show a lot of sedentary behavior might be at higher risk of developing cardiovascular disease, and people who have higher blood pressure might also be at higher risk of developing cardiovascular disease. We see here that the arrows from sedentary behavior and blood pressure are both pointing towards cardiovascular disease, to indicate that cardiovascular disease could be a result of both sedentary behavior and blood pressure. The green arrow here marks the difference between a collider and a mediator. We see here that the green arrow points from blood pressure to cardiovascular disease. If we had a mediator in our figure, the arrow would have been reversed, because a mediator influences the outcome. Because the arrows from sedentary behavior and blood pressure both point towards cardiovascular disease is not on the causal pathway from sedentary behavior to blood pressure, and therefore does not explain how sedentary behavior affects blood pressure. When it comes to distinguishing between third variables, I always like to think about the timing of each of those variables. So let's suppose that this arrow here represents time. We see the exposure on the left-hand side of the arrow, and we see the outcome more towards the right-hand side of the arrow. This indicates that the exposure takes place before the outcome takes place. Now, if you think about a confounder, then a confounder is a variable that affects the exposure and it affects the outcome. So in theory, a confounder should take place before the exposure and before the outcome, otherwise it could not affect both the exposure and the outcome. A mediator is a variable that is affected by the exposure and in turn affects the outcome. Therefore, a mediator should take place between the exposure and the outcome. So after the exposure has occurred and before the outcome occurs. A collider is a variable that is affected by the exposure and the outcome. Therefore, a collider should take place after the exposure and outcome have taken place. It is important to note that when it comes to this figure, time denotes when the confounder, exposure, mediator, outcome, and collider happen, not when we measure these variables. So just by measuring the mediator after the exposure does not mean that the mediator happened after the exposure. It's really important to think about the timing of each of these phenomena when we build our hypotheses. So let's summarize the basic principles. A mediator is affected by the exposure, and it in turn affects the outcome. Therefore, a mediator is on the causal pathway from the exposure to the outcome, and it explains how the exposure transmits its effect on the outcome. Subject matter knowledge is needed to justify your mediation hypotheses and to rule out that your third variable is a confounder or a collider instead of a mediator. We will now briefly discuss the mediation effects that are of interest when we do a mediation analysis. The goal of a mediation analysis is to determine what part of the total exposure outcome effect is explained by the mediator and what part is not explained by the mediator. A mediation analysis allows us to decompose the total exposure outcome effect into an indirect effect, which is the part that is explained by the mediator, and a direct effect, which is the part that is not explained by the mediator. We can also think about the indirect and direct effects in terms of the arrows in these figures. The indirect effect is the effect of the exposure on the outcome through the mediator. So it's the effect that is signified by the arrow from the exposure to the mediator and the arrow from the mediator to the outcome. The direct effect is the effect of the exposure on the outcome not through the mediator. The arrow pointing directly from the exposure to the outcome represents this direct effect. The total effect is the effect of the exposure on the outcome both through and not through the mediator. It includes the indirect pathway from the exposure to the outcome through the mediator and also the direct pathway from the exposure to the outcome. The total effect is therefore equal to the sum of the indirect effect and the direct effect. So let's go back to our example of sedentary behavior, BMI, and blood pressure. In this example, the indirect effect is the effect of sedentary behavior on blood pressure through BMI. In other words, it's the part of the effect of sedentary behavior on blood pressure that is transmitted through BMI. The direct effect is the effect of sedentary behavior on blood pressure not through BMI. The total effect is the effect of sedentary behavior on blood pressure both through and not through BMI. So in other words, it's the sum of the indirect effect of sedentary behavior on blood pressure through BMI and the direct effect of sedentary behavior on blood pressure. Just to summarize, the goal of a mediation analysis is to decompose the total effect into an indirect effect through the mediator and a direct effect not through the mediator. Now that you've learned about the mediation effects, it's time to start talking about traditional mediation analysis. Traditional mediation analysis is based on two seminal papers by Judd and Kenny in 1981 and by Barron and Kenny in 1986. Mediation analysis has traditionally been used a lot in psychological research. Epidemiologists only recently started becoming more interested in applying mediation analysis. In traditional mediation analysis, mediation effects are defined and estimated using linear regression coefficients. And in order to define and estimate the effects, we require the estimation of 3 linear regression models. Before I introduce the regression equations, let me share some common notation from the traditional mediation analysis literature. In this literature, the total effect of the exposure on the outcome is often denoted by C. The effect of the exposure on the mediator is often denoted by A. The effect of the mediator on the outcome by B. And the direct effect of the exposure on the outcome is typically denoted as C'. This first regression equation is used to estimate C. In this regression equation, y represents the outcome, I1 represents the intercept, and x represents the exposure. The C coefficient in this equation represents the estimated C pathway from the mediation analysis. In the second equation, M represents the mediator, I2 represents the intercept, X represents the exposure, and the A coefficient represents the estimated effect of the exposure on the mediator. In this last equation, y again represents the outcome, I3 represents the intercept, X represents the exposure, M represents the mediator. In this equation, C' represents the direct effect estimate of the exposure on the outcome. It's important to note that the C' estimate is different from the C estimate in the first equation because this third equation is also adjusted for the mediator. Then B represents the estimate of the effect of the mediator on the outcome. And it's important to note that we always estimate C' and B with the same equation. Because when we take a closer look at the figure on the slide, we can see that the exposure is actually a confounder of the mediator-outcome relation. So if we want to estimate that effect of the mediator on the outcome, removing any confounding effect of the exposure, we need to adjust for the exposure. In traditional mediation analysis, the total effect is defined and estimated as the C coefficient from that first equation on the previous slide. The direct effect is estimated as the C' coefficient from the third equation. The indirect effect can be estimated using 2 methods. The first method is called the product of coefficients method. To estimate the indirect effect based on the product of coefficients method, we take the product of the A and B coefficients from the second and third equations respectively. We can also use the difference in coefficients method, which equals C minus C prime. So C came from that first equation and C prime came from the third equation. When thinking about C minus C prime, it essentially represents the difference between the total and direct effect. And as we discussed when we were going over the different mediation effects, the total effect is essentially the sum of the indirect effect and the direct effect. So it makes sense that we could define the indirect effect as the difference between the total effect and the direct effect. It is important to note that traditional mediation analysis was developed assuming that we were using linear models. If we were to apply traditional mediation analysis to nonlinear models such as logistic regression analysis, then A times B and C minus C prime will not necessarily give us the same estimate of the indirect effect. Depending on the kinds of underlying models, there are different reasons why A times B and C minus C prime do not provide the same estimate of the indirect effect. In general, when we use nonlinear models to estimate the pathways in the mediation model, it is better to use causal mediation analysis instead of traditional mediation analysis. Although causal mediation analysis is beyond the scope of this introduction video, I do want to note that in causal mediation analysis, effects are defined based on counterfactuals. That is, the indirect effect, direct, and total effect are all defined in terms of counterfactuals rather than regression coefficients. As a result, these effect definitions are more general and can be used to estimate effects for any type of mediation model. There are also multiple estimation methods available, such as regression-based methods, weighting-based methods, and simulation-based methods. So let's summarize traditional mediation analysis. So traditional mediation analysis was developed based on linear regression models. The mediation effects are defined and estimated based on regression coefficients. However, traditional mediation analysis is less well suited for non-continuous mediators and outcomes. For those kinds of mediation models, it would be better to consider using causal mediation analysis methods. Now that we are approaching the end of this introduction video, I would like to leave you with a few take-home messages. First, it's important to remember that mediators are affected by the exposure and that they affect the outcome. Second, the goal of a mediation analysis is to decompose the total exposure outcome effect into an indirect effect through the mediator and a direct effect not through the mediator. Third, traditional mediation analysis is less suited for the estimation of mediation effects based on nonlinear models. Thank you for watching this video. If you have any questions regarding this video, please feel free to reach out to me or Dr. Valente, and we would be more than happy to answer your questions.